Hello, I'm Brian Bush from the Marlowe team, and I'll be speaking about running Marlowe contracts using the Marlowe command line interface tool. And we're going to do that right here without actually submitting transactions on the blockchain. So this will be simulating Marlowe transactions the way you might do in Marlowe Playground. And in a later lecture segment, we'll actually talk about how to submit the transactions on the blockchain. But it's often a good idea to simulate the contract before you run it actually on the blockchain. And so we're actually going to use a very familiar contract. This is the escrow contract that you can use in Marlowe Run, and you can also use it in Marlowe Playground. And so basically we have a buyer that wants to purchase an item, say it's a bicycle, they deposit their funds. After they deposit the funds, they might report a problem, like maybe the bicycle's the wrong color or something. If they don't report a problem, then the funds just go to the seller. If they do report a problem, then the seller may or may not dispute that. If they agrees there's a problem, the buyer will just receive a refund. But if they dispute a problem, then things move to a mediator, and the mediator decides who gets the funds. And then in addition to all this logic, there's logic around what happens if parties don't act, if there are timeouts in the contract. So here's a simple flow chart of this contract. We, in the Cardano world, we have to have a minimum ADA deposit to create a contract. So that's sort of the initiating event. The buyer then deposits their funds. They get a choice. Do they report a problem or not? If they don't report a problem, they say everything is all right, and it just releases the funds to the seller and the contract closes. Also, if they don't bother to report one way or the other, the funds will go to the seller. So this is the timeout path. If they do report a problem, as I mentioned, the seller can either dispute, confirm, or once again, they might not respond. So if they don't respond or they confirm the problem, there's a refund. If they dispute, the mediator has to decide. And if he dismisses the claim, then that means the seller gets the money after all. If he either confirms the claim or just is silent, the buyer gets their refund. So that's the contract structure. If you actually looked at it in the playground, in the Marlowe format, you'd see quite a bit of logic here about the different actions that are occurring. So this basically embodies that flow chart. And then in Blockly, we also have that. So here I've sliced up the Blockly output into 3 columns so it will fit on the screen here. But basically, this is all the same. So the Blockly is equivalent to the Marlowe, and the Marlowe is equivalent to the Blockly. Neither language is more expressive than the other. They're just different ways of looking at a contract. There are actually about 8 ways through this contract, and you can explore that in Marlowe Playground or at the Marlowe CLI. But basically, there's sort of the happy path where everything's okay. There's a dispute path where the seller says, yes, you're correct, it was the wrong color. Or sorry, there's a problem path where they say that's the wrong color. There's a dispute path where it goes to the mediator. And the mediator might rule for a refund or for it going to the seller. So in addition to these 4, there are the timeout paths. So basically at each decision, there could be a timeout. So that makes it so there are more outputs or more possibilities for the future of the contract. And so we're going to look at just one of those in this example. We have a seller, a buyer, and a mediator. And what's going to actually happen in this example is the buyer deposits funds, they report a problem, seller disputes, mediator rules for the seller, and then the seller receives their funds. In the flow chart, that's this path. And then if you were using Marlowe Playground or Marlowe Run, you would have to fill in various form fields. It would do discovery of wallet information, stuff like that. If you're running these at the command line, you don't have that luxury. You actually have to type in all this data at the command line. And what we're going to do is actually use variables in the bash shell. So all of these blue items are variable names. and then the green items are the values. So we have an initial loveless, which we're going to have a 3 ADA deposit when the contract is created. The selling price is going to be 256 ADA for this bicycle. And then we're using abbreviations, basically the initials of the parties for the rolls. That makes things a little smaller. It saves, a little bit of loveless and the fees and things like that. We also have a bunch of deadlines. We're going to make these relative to this moment. And all the times in Marlowe are in POSIX milliseconds. So you can look up POSIX milliseconds on Wikipedia and learn more about that. But basically, it's a counter in milliseconds that started on January 1st, 1970. So we have a payment deadline, a complaint deadline, a dispute deadline, and a mediation deadline. So we're going to set these variables, and we have to create the initial state of the contract. And the contract, we're going to store it in a file called tx1.contract, and its state, which is the initial state, in tx1.state. So these are both JSON files, and these basically give you a snapshot of what's going in the contract. The contract file says this is what's going to happen in the future. State file says this is exactly how things are now. So you need both of those to actually run things on the blockchain. You need the state and then the rules for the future. The Marlowe CLI template command has a bunch of example contracts, including the escrow one. So we're going to use that. And then basically you put in all these command flags with the data that we already entered into variables. So the minimum ADA of 3 ADA, 256 ADA for the price, the names of the people involved, the 4 deadlines, and then that we want to store this information in these files. So there we've created the contract, and then we want to look at the contract to see just what it looks like, maybe check if everything's okay. And even though we're using a JSON format for storing the contract, I'm actually going to show you the translations into YAML format, which is a very JSON-like format. It has a few extra features, but it's much easier to print it on the screen, and it's a lot easier for the eye to read. So we're just going to print that out. This is basically a convenient view of the JSON, which would be maybe a little bit harder for us to read here, at least in this lecture. So what is a contract? It's basically what we saw in the Marlowe language and in the Blockly. You've got all the timeouts, the whens, the cases, the deposits, the choices, the payments. But this is a JSON format. So these are all the JSON tags that would be in the JSON file. So that's all looking good. And then we're going to look at the initial state, and this is quite simple. The initial state, basically CM, which is the mediator, has deposited 3 ADA into the contract to start it off. So the account for CM just has 3 ADA, and basically nothing's happened, so everything's pretty empty there. Now, if you didn't want to use the template command, you could actually create the Marlowe contract in other ways. You could use Playground, the Haskell, the JavaScript, or the Blockly. You could use Python or Rust or Julia or whatever language you want, as long as you can output a JSON file that conforms to the Marlowe schema. So it has to be a properly formed JSON file, but it really doesn't matter how you create the contract. We're giving you the Marlowe CLI is one way to conveniently do it. We have a lot of examples in Haskell. We have the Playground, so you have many options for that. So let's say we designed it in the Playground. So you just do the whole Blockly thing there, or however you want to design it in the Playground. When you click Send to Simulator, you'll see there is a Download as JSON button, and just save the file into tx1.contract, and that will basically be identical to what we've created here from the command line. Now, Playground does not create the initial states. We're going to have to do that by hand. And it has the pre-existing account balances, choices, assignment of variables, and minimum time for the contract to be running. So we're going to basically just type this in here. Um, and then we'll take a look at that, and we can see we basically got exactly what we had before. So this is just an alternative if you're using a text editor or scripts or something else, some other tool to create the initial state file. And it's mostly useful if you're not using the template command, because the template command will create that file for you. Now we have to step back a little bit. We are actually going to do something on chain right now, which is minting the role currency. So in the contract files, there's a reference to the role currency symbol, and that's also called the policy ID for the token. So basically, we need to know what that is because we can't do the simulation unless we know what the roles are going to be. So we're going to do a little bit of a transaction here. We're going to use the Marlowe Pioneers testnet, so its magic is 1567. And we'll use the Daedalus socket path for the node. I have Daedalus running. And then we're going to mint tokens using a utility in Marlowe CLI called mint. So we tell it the signing key that we have, the change address, like where all the leftover 8 is going to go from UTXOs that are used in the minting process. We're not going to keep a record of the transaction in a file. We could do that if we want. We're just going to throw that away. And we're going to wait 600 seconds for the transaction to be confirmed. You can see it was actually confirmed while I was talking, so it was just a couple seconds. We're creating 3 tokens, the mediator, the seller, and the buyer. So this printed out the policy ID. We're going to keep a record of that because we'll need that later. So we're putting it in a variable. And then we're going to actually make sure, like, hey, did these things really get minted? So we'll query the blockchain, and you can actually see we've got 4 UTXOs. The first one was the change, and then the 3 UTXOs for the tokens that have been minted. And so at this point, we don't really care about all the details of these UTXOs. We really just needed the policy ID. So in another lecture segment, we'll pick up from here and we'll actually use these tokens. Right now, we're just doing simulating, so we don't really need to do any more transactions. So step 1, the mediator is going to be the person creating this contract. As we mentioned before, they're going to put 3 ADA into the contract just to get it started and to satisfy the minimum ADA requirement on the Cardano blockchain. And that, as we saw in the state file, is going into their account. So basically what we have is Christopher Marlowe, who's the mediator. At the contract script, they're going to have 3 ADA in their account. So we have the contract script, as we explained in the first lecture. We also have a payout script. So nothing's happening at the payout address right now, but at the contract address, we're going to put 3 ADA there. This corresponds to the very beginning of the flow chart. And then I printed out here in very small type the contract that remains to be executed, and it's basically everything. So this is kind of where we are. We have to initialize the contract. And what this does is it takes the state file and the contract file, the TX1 contract, TX1 state, you can see right here in our initialize command, and it outputs a Marlowe file. And this Marlowe file has a lot of stuff in it. It has the state and the contract. It also has all the addresses, all the Plutus code, all the things like that. So it's sort of one-stop shopping for Marlowe information. And as we do the simulation or as we submit transactions, we're going to be using that file. This is just convenient to just bundle everything together. Otherwise, all these commands would have many, many more arguments and maybe be a lot more error prone. So we're going to initialize the contract. And we said, print statistics. So it gives us a little bit of information. The Marlowe validator is 12 kilobytes. And there's kind of a rough cost estimate of how much it'll cost to run the Marlowe validator. This is basically a general guidance because individual transactions will cost different amounts, but you can kind of see where you are in relation to the protocol parameters. And when we submit transactions, we'll go into that in more detail. So let's look at these files. We've got our state file, our contract file, and then our new Marlowe file. You see it's quite a bit bigger. And we're actually going to print this out and just look at a couple things in it. So you can see it's got a contract entry, which is just the contract we had. It has an inputs. There's no inputs because we're just creating things. So later on, there will be inputs entries here. And then we have information about the validator. So the script address for the Plutus validator that interprets Marlowe on the blockchain is this. We have those cost estimates. There's the script hash, and here's the actual serialization of the Plutus code. So lots of binary data. And then little information about this is how big it was. There are no payments being made. There's really not much going on here, so the time range of the transaction, there's no limit on that. We do have the record of the rolls currency that we mentioned before. And then the same information as we had for the main Marlowe interpreting script also occurs for the validator. So we have its address, its cost, its hash, and then the actual validator script, which is a bit smaller there. And then some information about the actual network we're using. This is basically how time relates to slot number on the network, the initial state that we input. So a lot of stuff there. And this is actually useful. Like normally you don't have to look at it, but you could actually query this and pull out information. And we'll show a little bit of that later. So the first real transaction after creation is just making the deposit. So the buyer is going to deposit their 256 ADA for the bicycle. So there's the buyer. The contract specifies that when they make the deposit, it actually goes into the seller's account in the internal bookkeeping. And so we're basically going to have this. And so the script will have 259 ADA. 3 of that belongs to the mediator. The rest of it belongs to the seller. And we've progressed this far along the flowchart. And then I've grayed out the part of the contract that has been executed. So just the very beginning has been executed. There's a lot more to execute. So basically that's what's going to be happening in this step. So how do we actually do this? So Marlowe CLI has this prepare command, and it's basically all about making inputs. And so this input is going to be a deposit. And so we're going to start from where we left off, which is transaction 1, and we're proceeding to transaction 2. So these prepare commands kind of move you from one stage to the next stage. And we're depositing into the seller's account by the buyer that amount. And we're saying for this transaction, we're going to say anywhere from now, when we created the contract, for the next 9 hours. We're going to do it sometime in that time window. And once again, we'll print statistics. So statistics are pretty minimal here. Just means that the Plutus datum is going to be 463 bytes. You can see the file up here. So now we have a second file. It got a little bit smaller because we have a smaller contract that remains to be executed. And then let's take a peek here. Let's look at the inputs part of that file we just created, tx2.marlowe. I'm not going to print it out again because it's very lengthy. But you can see it has a record of the inputs. So, from the party, the buyer to the seller, it's identifying them by the roll tokens, and it's saying 256 ADA. So that looks good. The state of the contract, as I said before, the mediator has 3 ADA, and then the seller has 256 ADA in their internal account. No choices or anything have been made. And then you can see that the minimum time has changed. So future transactions have to occur after this time. We look at the contract. This is basically what I had highlighted in red. This is the remaining part of the contract that can be executed. But the main thing here is that if you're confused about what's going on in your contract, you can peek inside this Marlowe file and kind of see like, oh, this is what's left to do. These are my choices, things like that. So sometimes that's useful for debugging if you get confused or if there's some sort of issue going on. Now, the buyer is going to report the problem in step 3. So we move a little bit further down. We're kind of down on this branch here in the flow chart. And according to the rules of the contract, when there's that reporting of a problem, it actually causes an internal change in the datum of the contract in the state. So it's actually internally going to move that 256 ADA that was in the seller's internal account into the buyer's internal account. And the real implication of this is if there's a timeout, the buyer is going to get their refund. If we had left it in the seller's account when there was a timeout, the seller would have gotten the money. So this is, an important decision to make when designing a contract. What happens when timeouts occur? So we have a little bit less contract here. Just the red part remains to be executed. The gray part has already been executed. And the prepare statement is similar, except instead of making a deposit, we're making a choice. So the choice is just called report a problem. We put in that text string. The buyer is doing the report. It happens to be called choice number 1 in the contract logic. And then we're just saying we're going to submit it in this time window. And so we're moving from stage 2, step 2 here with this Marlowe file, into the TX3 Marlowe file. So the TX3 Marlowe file will have the new information. So here we have a little bit more information here. We have a datum, which we had before, but we also have information about what is actually happening in this simulation we're doing. So we're basically paying from one account to another this 256 ADA. And so this is what we looked at in the diagram before, but this is how it actually is reported by the CLI tool. So we've got more files. This TX3 Marlowe, still getting a little smaller because we have a smaller contract. We will look at the inputs. This is how they show up in the JSON. It just says report a problem, who's reporting it, its choice number. So you see, you could do all of this more manually, and you could actually do this with the low-level functions of Marlowe CLI, where you would actually have to create a JSON file like this. You would have to serialize it to convert it to a datum file, and then manually submit that with one of the Cardano CLI tools. What Marlowe CLI is doing at this high level is just managing all this bookkeeping on JSON to datum, how to apply inputs, things like that. So the state, only difference here really is that a choice has been made. So there's a record in the history of the contract of that choice. The time has been updated, and you can see now this is in a different account here. So we'll look at the contract. I'm not going to dwell on this, but you can see it's a little bit smaller. Now the next step is the seller is going to dispute the problem. So they have this choice. They decide they're disputing in the flowchart here. This actually doesn't do anything to the accounts of the contract. It's just a piece of logic choice that's being recorded. But you can see we have very little contract left here in red. And it's pretty much identical to the previous step in moving from step 3 to step 4, except the text is dispute problem, and the role is the seller, and they're making a choice called 0. So we're generating this TX4 file starting from step 3, applying these inputs. Okay, and you can see the datum smaller, we have the file, and then the input is very much like before, except the text is slightly different. State didn't change in terms of the internal accounts, but it did change in terms of the record of choices because this choice has been recorded. And then the contract is getting quite a bit smaller. Now it fits on one screen here. Now the mediator has their turn, and what they're going to do is actually they're going to rule for the seller. So they're basically saying the buyer was not correct in reporting a problem. We go through this logic here, where the mediator decides, and this is going to trigger a lot of movement of funds. So, because the contract is actually closing here, all that's left of the contract is this close statement, and the contract won't live on the chain anymore once it's closed. So the seller, their funds, they're getting their funds back in their internal account, and that's actually moving to the payout validator. The mediator, the 3 ADA they deposited originally, is going to the payout also. So a lot of movement of here. Things are getting kind of cleaned up and wrapped up. The transition from step 4 to step 5 is just like the previous transitions, except the mediator is doing it. It's called dismiss claim, and the choice number happens to be 0 according to the rules of the contract. So we're going from this TX4 to TX5. So we'll run that. And then you can see all this activity here. So there's an internal movement of funds. This is a payment from an account to an account. Those funds are later moved out of that account to the actual payment address. And then in parallel with that, the 3 ADA are moved out of the contract. So basically the contract is getting cleaned up. We've got one more file. It's a little bit smaller. The inputs are recorded like we did before. The state of the contract. There's nothing in any of the accounts because the contract is closing. And we just have the record of basically the choices that were made. And then the contract is dead simple. It just says close. So this is basically how you run a contract beginning to end when you're just doing simulation without on-chain transactions using Marlowe CLI. So we use the Escrow contract. There's actually a whole bunch of other contracts. Right now we've got 5. A super simple one that's great just for studying things if you want the simplest sort of situation of a contract. A token swap, a 0 coupon bond, that's like a loan, and then a covered call, which is like an option. And we have a lot more examples and templates either in the playground. We have a whole folder in our repository of different example contracts. So these are really proliferating right now. Troubleshooting. So what could go wrong and how could you diagnose it? So if things go wrong, try it in the playground. That's a little bit friendlier than typing at the command line. If you can get it to work in the playground, try to mimic that at the command line. I've mentioned before, be careful about timeouts. That can sort of trip you up, and both from a design perspective and also executing the contract. And then you might get errors if things are wrong. Typically, you won't see these except if you're telling Marlowe CLI kind of an invalid range when the input needs to be applied. Like it's either too late, it's in the past, it's ambiguous. So you will get an ambiguous time interval error if you say this transaction has to occur in a time that straddles one of the timeouts. Because what that means is Marlowe can't tell, well, is it submitted before that timeout or is it submitted after? Because the contract would proceed differently. So that's the ambiguity there. If you're trying to do something radically wrong, like make a deposit when you're not allowed to, you'll get a no match error. If you have a really malformed time interval, like the beginning is before the end, or as I mentioned before, it's in the past, you'll get an error like this. If you're doing a transaction that doesn't change anything, you'll get useless transaction. And if you happen to be using the Merkleization capabilities, which we're not talking about here right now, you could actually get things like hash mismatch. In terms of resources, we have an expanded list here. There's the CLI documentation. We actually have a debugging cookbook that kind of gives some recipes that we're building up on how to debug problems in a contract, from just basically understanding some of these time interval mistakes that could be made to how do I debug Plutus? So it's kind of all skill levels here. And then, as I mentioned, we have some example contracts. in many different places. You've used run, and then we have the standard documentation for the bigger picture. So exercises, these are really all sort of optional. It's really up to you what your learning objectives are, but here are some things of, easier or intermediate difficulty. One is, simulate the same contract in the playground. So the example we did, do it in the playground. So you don't actually even have to use Marlowe CLI to do that. Another thing that's pretty easy is repeat what we've just done, but mess it up a little bit. So maybe make a choice instead of a deposit, or change the choice to an illegal character string that's not in the contract, or fiddle with the times. Try to see if you can get one of these errors that I showed you before, and that should be pretty easy. You can just, even things like depositing the wrong amount of ADA will give you an error. So the idea is, I kind of showed you the happy path through the contract where everything works, and but if you've made a mistake at the command line, you will get an error, and that's what Marlowe is supposed to do. It's supposed to detect invalid inputs. Another thing you could do would be do the same simulation, but have the seller say, actually, everything is okay. The bicycle was the wrong color, and they don't dispute it. And so then the flowchart will progress a little differently. The other thing is try to do a timeout in this. So try to trigger the timeout logic. And basically the way you would do that is you're not applying any input in terms of deposit, notify, or choice, but you're just submitting, you're using prepare just with a time range that is beyond the timeout. So you can explore that. Once again, using the playground simulator kind of gives you can help you build a mental model for what would happen at the command line. The other thing would be, instead of doing the escrow contract, run a different contract. So those are different things, as I said before. What if any of these you pursue can depend on your learning objectives. So in summary, what we have is we have a command that generates some example contracts. Those contracts are just JSON files, so however you want to make them is fine. The playground is another easy way to make them. The state of a contract is the account balances, the choices that have been made up to that point, the assignment of variables up to that point, and then the minimum time when the contract can actually run. So that's in the state. That's stored in the Plutus datum when it's on chain. We have the initialize command that basically is packaging things together into one of these Marlowe files. We have the prepare command, which is for applying inputs. And then we also saw we had to use the mint command to mint some roll tokens and get the basically get the policy ID or the currency symbol for use in the contract. So thank you.